The next and final applications are mixture problems. And we're just going to do a couple of them. You'll do a couple of them in this section. You can do it. In this, I just put in a reminder about what you need to do when you're solving problems. So now we're just going to jump into it. A chemist needs 10 liters of a 50% salt solution, but all she has available is a 20% and a 70%. So she wants to know how much she needs to mix of each solution to get a 50% solution. So this is how they're going to be set up. When you go to do My Math Lab, you should copy these so that you can do the chart form, because it'll be easier. So we have a 20% solution, so I'm going to put 0.20, and a 70% solution, 0.70, and we want to get a 50% solution. So far so good. It says how many of each should she use? And she wants to get 10 liters, so we're good there. And she wants to get X of the first. We don't know the first. And yes, we could put Y in the second, but we're not going to do that because this is my total. This is my part. So the other part is going to be the total minus X. So the amount of pure salt is the percentage of pure salt times the amount of the solution to get the amount of pure salt. That's why I love this table so much. So it's 0.20x, 0.70 times the quantity, 10 minus x, is equal to 0.50 times 10, which is 5. And the other beauty is the amount of salt in solution 1 the salt amount in solution 2 better equal the salt amount in the mix. So this is the beauteous, because this will always be your equation right here. 0.20 x plus 0.70 times 10 minus x is equal to 5. And then all we need to solve. Here we go. 0.20x plus 70% of 10 is 7 minus 0.70x is equal to 5. Combine like terms on a side, you guys. Minus 0.50x plus 7 is equal to 5. 0.50x is equal to negative 2. What did I just do? I moved this over to the other side as a negative 7. And here I just combine like terms, and then I'm going to divide. So x is equal to 4. So now let's write our solution. Yay! All right, so x is 4 here. 10 take away x is 6, right? 10 minus 4 is 6. So we will need 4 liters of the 20%. Just use your table because this is your 20%. And 6 liters of the 70%. Okay. Next, the old coffee problem. A manager in a coffee shop has one type of coffee that sells for $5 a pound and another type that sells for $15. So the cheap is $5 a pound. The more expensive is $15. And of course the manager wants to mix them. And he wants to, or she wants to mix 50 pounds of the $15 coffee to get a mixture that sells for $9. How many pounds of the $5 coffee should be used? good. I love these because they're right in there. Everything's great. So what's the total? Well, this is part. This is part. So I got to add them to get my total in the barrel. And the beauty is, how much money is tied up in the expensive coffee? Well, 15 times 50 is $750. How much money is tied up in the cheap coffee? 5x. How much money is tied up in the mixture? 9 times x plus 50. And what's the beauteous part? Yes, the equation is right there. So 5x plus 750 is equal to 9 times x plus 50. Let's solve. So 5x plus 750 is equal to 9x plus 450. So I'm going to bring the 5x over to the other side. Ooh, I'm going to do a double whammy. The 450 over to the left-hand side. So I get 300 is equal to 4x. X dividing both sides by 4. 300 divided by 4 is 75. I'm just checking myself. All right. So the sentence. We need 75 pounds of the cheap coffee. Ta-da! Yay! Now you're able to do the few mixture problems that we give you in my math lab. Good luck. Ask lots of questions. Refer back to this in your notes. Set up the table. You can do it.